All right, we're going to talk about mean and variances for binomial distributions. So with a binomial distribution, we know that there's only two possible outcomes, and there's a probability of success and failure. When we read through the problem, we're going to have to identify those, and also the number of trials that we're looking at. Not all visitors to a certain company's website are customers or potential customers. In fact, the company's executives estimate that about 5% of all visitors to the website are looking for other websites. Assume that this estimate is correct. So 5% of the visitors don't want to be there, 95% do. They're going to take a random sample of 50 visitors. So if you did like a tree diagram of that, 50 trials would just be ridiculous. And it's a good thing that we don't have to do that and then figure out the distribution, and because there's a nice shortcut formula that will give us the mean or the expectation without having to go through all that. It says, here's the problem. It says estimate the number of visitors in the sample who are actually looking for the company's website by giving the mean of the relevant distribution. That's the expectation. So if they say that 5% aren't looking for it, then 95% are, and 95% of 50 is 47.5. You just do 50 times 0.95 because the formula that's given on page 282 is that mu, or E of x, equals n times p, where n is the number of trials and p is the probability of success. This is q though. Okay, so and then quantify the uncertainty of your estimate by giving the standard deviation of the distribution. And we're going to round that to 3 decimal places. This one we got 47.5. Now truly we can't have 47.5 visitors, but because it says do not round your response, I didn't round it. This one, standard deviation, we're going to round it. And you can see I already did. I did this a second ago, but I didn't like my video completely, so I deleted it. But it says quantify it. The uncertainty. We know standard deviation is the a measure of the dispersion. Well, it's also a measure of uncertainty. Because if our expectation is the mean, then how spread out the values are around that mean gives you an indication of how uncertain your estimate is. If they're very spread out, then your estimate will lack certainty. If they're tightly grouped and your standard deviation is low, then you can be more certain about your estimate. So, how do we get it? The formula is the square root of n times p times q. I'm not going to derive that. You don't want to see the derivation. Just trust that it works. If you're math minors, or you were taking this in class, I might show it to you. I might do it out on a sheet of paper or something, but not for this class. And when you take the square root button of n is 50, times p is 0.95, times q, which is 0.05, you get 1.5411, which we round to 3 decimal places and get that. So that's our answer. It says good, we'll practice again, we'll do another one. It's very simple. Anita is a fast food chain specializing in hot dogs and garlic fries, keeps track of the proportion of its customers who decide to eat in the restaurant, so it can make decisions regarding the possible construction of... This seems like the introduction to another problem we had. Anyways, Anita's reports that 48% of its customers order their food to go. Suppose this proportion is correct, and a random sample of 40 individual customers is taken. Okay, so n is 40, and 48% order to go. Estimate the number of customers in the sample who ordered their food to go. So we're going to use the 0.48, and we're going to multiply it by 40, because our expectation is 40%, or 48% of the 40 order to go. And I think that's like 19.6. Is that correct? Who knows? I don't know. Let's check it. 48% might be 19.2. Who knows? All right, so 0.48 times 40 is 19.2. Okay, there we go. All right. Now we want to quantify the uncertainty, and in the same way as we did it in the previous example, we're going to do the square root of n times p times q, where n is the sample size, which was 40, p was 0.48, and q is 0.58, and we hit enter. What is this? 3.337, rounding to 3 decimal places. We'll call that 3.337. What comes after? 0. So it'll be 3.337. Okay. And that is all she wrote for that problem. Oh no, what did I do? 3. Your answer is incorrect. What did I do? 0.48, 0.52, 40. Let me calculate it again. Square root 40 times 0.48 times 0.52, enter. Oh, 3.1. I'm not even close. I don't know what I hit last time. 3.1597. The 7 is going to tell us to round this 9 up to 10, which makes this a 6. So it's 3.16. Ah, 16. There we go. Whoops. All right. And since I messed that up, what time is it? Yeah, we have time for one more. So we'll hit practice one more time. Okay. This time it's 98% of individuals are predisposed to allergies, and there's 130. 98% of individuals who are predisposed to allergies find relief using allergy vaccinations. And we're going to take a sample of 130 individuals who are predisposed to allergies. And they want us to estimate the number of individuals in their random sample who do not find relief by getting allergy vaccinations. Well, the ones who do not are going to be 2%. And 2% of 130 is 2.6. All right. Quantify the uncertainty of our estimate by giving the standard deviation of the distribution. Now, technically, the p is, because we're talking about this estimate, the p is 0.02 and the q is 0.98, but it doesn't really matter because we're multiplying. It's a product. The order doesn't matter if we put the 0.98 before the 0.02. But we definitely have to have both of those numbers in there. 130 times, but I'll do it properly, times 0.02 times 0.98. And it looks like 1.5962, which we'll call 1.596. And so that is completed. And heck, we have time for one more. Let's do it. Okay. A machine that manufactures automobile pistons is expected to produce a defective piston 1% of the time. So 99% of the time is good, 1% of them are defective. Suppose that this estimate is correct and that a random sample of 80 pistons produced by the machine is taken. So 80 pistons are taken. You know they're going to ask you for the expectation here. What's 1% of 80 is 0.8. So they would expect around 1. Or sometimes none. Quantify the uncertainty of our estimate by giving the standard deviation. So the standard deviation is going to be the size of our sample times the probability of picking a defective one, which is 0.01, times the probability of not picking a defective one, which is 0.99. And our answer is 0.8899. So we're going to call that 0.89 because it rounds up. And that's it. Very good. We seem to have learned it. We're done there, and we're done here. Bye-bye.